All right, we're on number 6. I'm going to use the rational root theorem and write down the candidate rational roots. The factors of 39 are 1, 3, 13, and 39. And the factors of 4 are going to be 1, 2, and 4. All right, the next thing I would do is just kind of test some easy ones out. And I'm going to call this thing f. F of 1. It's an easy one to test, by the way. What do you get? You get 4 plus 16 minus 7 minus 39. And there's no way that's 0. But it is less than 0. I know that much. And I'm going to try f of, well, the next one I'm going to try 3. Might be lucky. What do you get? 4 times 27 plus 16 times 9 minus 21 minus 39. Well, that's not 0, but I do know it's greater than 0. And someone says, why do you want to know that? Because now I know between these two numbers, there's a root. So between the number 1, this along the x-axis, and the number 3, 3 is positive, 1's negative, and by the intermediate value theorem, I know there's a connection between the two. So there's a root there. I know there's a root. What I'm hoping for is rational. It's going to reduce the amount of choices I have. So if it's rational, what are the numbers in the list that would, that would work between 1 and 3? Well, certainly 3 over 2. Let me try that for you. 3 over 2. And what would I get there? I would get 4 times 27 eighths plus 16 times 9 quarters minus 21 halves minus, I'm going to give things in terms of halves, by the way. That's going to be 78 halves. And I'm hoping that's going to be 0. 2, right? That'd be 27 plus 72 minus 21 minus 78. Well, 27 and 72 is 99, and minus 21 and 78 is minus 99, so it's 0. This is good news. So now I know I got a factor. So, x minus 3 halves. But I prefer to write this as 2x minus 3, and then I have a quadratic left over. And what's quadratic going to be? It's going to be 2x squared plus bx, I don't know what that is, and then let's see, plus 13. That equals 0. All right, and I'm going to equate coefficients because for me it's easier than doing the division. So there's 16x squared, right? And where would that come from? Well, minus 6x squared. And then what else would you get? You would get 2bx squared. That doesn't look too bad, right? So what does that mean? 16 equals minus 6 plus 2b. And then I would get 22 equals 2b. So b is 11. Let me get my eraser out. And b is 11. Sorry about that. And I'm going to check it. And someone says, what do you mean you're going to check that? Are you going to multiply everything together? Not really. All right, let me erase this over here, erase this over here. This is good too, we can get rid of that. And, I just noticed that 2 of the roots are missing here. Candidate roots, by the way. It looks like 39 halves and 39 quarters is missing from the list. All right, let's just check it out. Would you get 4x cubed? Of course you would. Would you get minus 39? Of course you would. Do we get the middles, though? I don't know. Let's take a look. You get minus 6x squared. And let's see, plus 22x squared. And what would that give me? Yeah, 16. That's good. Now, do we get the minus 7? I don't know. Let's take a look. Minus 33x. And then 26. And what would that give me? Let's see, minus 7. Yeah, perfect. It works great. All right, so I'm good. And I want to go further than that, though. And I'm looking at that. I'll write it down for you, maybe a little clearer, too. 2x minus 3. And then you get 2x squared plus 11x plus 13 equals 0. And I think you probably know I want to try to factor that. Well, what's nice about that factorization, very little choice, by the way. So, I'm going to say 13, 1. Let's see, would that give me 2x squared? It would give me 13. No, it's not going to work, is it? Because you do get the 2x squared, you get the 13, but 2 and 13 is 15. No, it's not going to be rational. So, I've only got one rational root. The other ones are going to be irrational. All right, let's see what we got over here. Yeah, they list the irrational ones out, all right? So they do it by the quadratic formula. But I think, let me just read the question, though. Yeah, they're just looking for the rational root. There's only one. And the only rational root here is 3/2. I used the quadratic formula on this to get the other ones. And certainly we've done that many, many times before. You may want to go out and verify that, all right? But again, a graph is given to you and all that kind of stuff over here. Granted, I do the work a little bit differently. The reason for that is sometimes I like to do long division. Sometimes I don't. It's up to you. Right? Am I getting the same results? I am. I will make the correction in the key. I'll put these down in the list. All right? Thank you. Oh, before I forget, if you think I made a mistake in the document, please reach out to me. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. And again, my name is Ron Bannon. Thank you for paying attention.